let me see. Right, every problem has its own points, right? So for simple ones, we give smaller points, and for a little bit more complex ones, we give more points. And for each of the points, we actually include both the functionality and the readabilities. Right? For all of them, we'll probably allocate 5 points for readabilities. What are bad readabilities? What are the examples of bad readabilities?
I call it code in one line.
Yeah, reading your code in one line. And all your variables are A, B, C, D, E, F, G, H. Right? Give some meaningful names to your variables. And for a bunch of blocks, try to use at least one line of comments to explain, okay, what's the meaning of the following lines, right? These are some types of good readabilities, right? And these kind of readabilities will make your code more readable for others. And also, for this range, right? We said our input would be n would be less than 2 to the power of 20. You might ask, okay, how could the TA test my program using so many numbers, right? Is it possible for the TA to type in so many numbers? Maybe you have this kind of questions, but do remember, we will test you on this kind of inputs. We will give you 2 to the power of 20 numbers to test your program. All right? And similarly for the next one, even though we give numbers like PQR, you could rename it to some meaningful variables, right? For the base B, you can name it as base, for example, in your homework, and so on. And anything we didn't ask you to output, do not output, right? If our sample input is like this, sample output is just a 4. Don't write something like, okay, the second largest number is 4. Do not write it that way. Just output 4. All right. Any questions on homework? Any questions? All right. So let me go to the home page. So 2 of the TAs will be responsible for grading your homework, Newton and Serial. So these 2 TAs, they will grade your homework, right? They will write a bash automatic script to run your code, and they will also look at your code to see the styles or the readabilities. And in the class, maybe I will give some hint on homeworks. I don't know. Let's see. Where are we last time? Right. So we have talked about functions, right? You can, so one good style is don't put every code inside your main function, right? Using some functions to modularize them. I will talk about that later. And then you can see we can define some functions like this. This function, we can use one line of comments before these functions, saying, okay, this function, what does this function do? This function will do if x and y, the difference are less than a small number, we return a true, saying they are approximately equal, right? And write something like that, so that other people will be understand your code. And also give good names to functions, right? Not just f. People will not know what f means. But if you put some names like approximate, equal, people will probably guess without looking at your code. They will probably guess you are implementing some functions that's checking if x and y are approximately equal. Right. So this is the function. Last time we said in the main function, we can call this function, right? And we'll put x and y into this function, and this function will return a value, which is Boolean. Boolean is either true or false, right? We said if they are approximately equal, we can say they return a true, or if they are not equal, we return a false. This type of functions, we call it a predicate. This is the name, predicate. This is a function that returns a truth value. You don't actually remember the name, but this is something we typically call it. And the parameters. So a function can take many parameters, right, as you defined in your function definition. In here, we take three input as the parameters. So this future value is a function. It takes 3 inputs, right? And we haven't seen its actual type, but we can see here is defining definition of the type, right? Future value. It accepts three parameters. First one is a double. It's the initial value. Second one is a double. It's a rate. Last one is the number of years. It's an integer, right? So when you call this function, it's actually jump into here. And what they will do is they will assign values to it. Total divided by 2, go to initial, rate, go to p, year 2 minus year 1, go to n. And we can see. So the first question is, will the parameter be changed in the code, right? If we can see here, p changed, right? Here, p got the value of rate. So will rate change after this function is called? So this is the question, right? Because we say when we call this function, total divided by 2 will go to initial, rate will go to p, year 2 minus year 1 will go to n. And inside of this function, we changed p, right? P becomes 1 plus p divided by 100. So the question is, will the rate be changed? Because p holds the value of rate. No, right? Yeah. The answer is no. And the reason is this p is only local for this function. And in next lecture, we will learn, maybe today's class, we will learn how to use a reference. We'll put a reference here. When we change p, we can also change rate. But that's another story. So if we look at how the parameters are passing from the main function, here's the main function. All right, here is the future value function. And inside the main function, we have a bunch of variables. These are the variables defined in main function. The total, the rate, the year 1, the year 2. Here are the variables defined in the main function. And when main function calls the future value function, we said total divided by 2 will be evaluated and a copy to the initial balance of, actually in the previous one we call initial, will be copied into the initial balance. The rate will be copied into p, and the year 2 minus year 1 will be first evaluated, then be copied to n. p is the return value of future value. So when it's computed, it will be returned back to the main function and assigned to some variables. All right. So any questions on how parameters are passing from the caller to callee? Main function is the caller. It calls the future function. Future value function is called the caller, and the future value function is the callee. It is being called. Any questions on this? No? All right. So there are many errors that may happen, especially in C++, because we are strongly typed. For the first one, for example, for the square root function defined in the standard library, we asking the parameters should be a double value, but you are giving an integer. No, it's a string, right? If we put a string here, it will be some errors. Right? Compilers will say this one doesn't match. And the return value, right? Square root returns a double, and if you assign a double to a string, again, it's an error. So the type of mismatch problems will sometimes happen when you are calling a function. Remember to be careful about the types. But there are some types that can be converted. For example, this number, if the number is integer, it's okay to call x equals square root of an integer, because integer can be converted into double, right? It also applies to some other any type that can be converted into double. Another name, we call it procedure. It's from very old programming languages. So this one, for example, print time, right? It didn't assign to somebody when we call this function. We just put the name here. And as you can see, this print time just to print out, just to see out some information. We don't ask it to return anything. So our return value is void, or we didn't return anything. So we don't need to assign the value of print time to some variables, right? We just do some work. So it's quite common when you are designing your, especially when you go to the vectors or some other things, especially when there are some reference parameters in here, you can modify that reference, and then you don't need to return anything. So here, use the void, right, to represent you don't want the function to return anything. So that's the goal. And then because it doesn't return anything, it must have some side effects, right? Otherwise, why do you just call this function, right? If it doesn't include anything. And ideally, including functions or procedures, making sure there's only one functionality inside it. Do not mix all the functionalities in just the one function. That is bad for readability. And here is, we call it modularization, or we say keep the functions short, right? And the functions need to be documented, short and documented. For example, square root, right? When the function square root is defined, we only put the square root function inside, right? Don't put some other things like calculating the root of a quadratic formulas and so on. So you should modularize it. So when you are designing your homework as functions, also think about it from that way, right? How can you modularize your homework, right? For every function, assemble them into different functions, and let them call each other, right? And the functions need to be, typically we want the functions to be short. How short it is, it depends on the real functionalities. But one rule would be typically, if you cannot view the whole code of your functions in just one page, it maybe means it's too much, it's too long. Break your programs into easy to test pieces. And when you are trying to test all the programs, try to cover all the possible paths and edge cases. And that's the idea of test-driven development. So let's look at one example, right? Let's see. Okay, so we are trying to finish the task. How do you get the coffee, right? So here is, for example, if this one is a homework, you would first ask is, if this is the problem, right, how can we solve it? There may be different ways to solve it. Maybe we can ask someone else to do it, or maybe we can make coffee. For example, if we choose to make coffee, right, we should make another decision, right? Should we make instant coffee, or should we brew coffee by ourselves? If we make instant coffee, we can start by boiling water, etc. How can we define functions? In our main function, we can say make coffee. Make coffee is another function. Inside main function, we can say, okay, maybe you can say there's another function called boiling water, right? And then another function, then another function. So here is the, how can you modularize your program? We will see it by some examples later. And next is about unit testing. Whenever you finish one program or one function, try your best to test it, right? If you have some functions you have written that can convert an integer to its English name, right? You can test it like this. You can assert the function, the input equals some output. These are some predefined ones. It's like TAs you're upgrading your homework, right? TAs will give some input, test if your output matches this correct output. Right? They will have this kind of input output pairs, and they will check each one of them. And indeed, we don't need to build it that way, but I will not talk about some other frameworks, such as Google Test, the Booster.test, Cache2. They are the frameworks that can help you to do better unit testing. So whenever you run a function, you can use this kind of framework to test each one of them, writing unit tests one by one, and test all the functionalities. But it's beyond the scope of the class. I just want to let you know if in the future you are writing large programs, try to use these tools. Next one is the debugging, right? When you are while you are running your code, and after you finish it, you want to know what's happening in the middle, right? You don't have to print out every variables. You can use debuggers, especially from the IDEs. Use these debuggers to see what's the values while it's running in the middle, so that you can have a better understanding. And I will use that. I will post it here. And right here is a very simple example. I have a function f, a function g, function main, and main will call g will call f, and so on. So the question is, how can we debug it, right? All right, so many IDEs provided this. Let me see if I have it. Yeah, here. So here is the function I copied from my slides. And there's something called breakpoints. You can create as many breakpoints as you want, right? You can breakpoint every place, every line. Breakpoint means when the program runs, you want it to stop here. You want to investigate what's the values of each functions. But let's run it. Right? Let's see first to see what's the functionalities. Right, main function. We'll first 1 to I, then call this g function and assign it to b. Let's look at how can we debug it. So when we debug, it will stop here, right? Because I created the first breakpoint. We said main function is the entry point for a program. So every program will first run from line 22 is main, right? Then execute line by line. I ask it to stop at the first line. And in here, you will see the values. If I break it in this line, means this line hasn't been executed. So I have defined a variable I, which is integer, but I haven't assigned 1 to I. So for now, I is just some random number, right? You don't know. The random number, and also B is also some random number. These are random. And as you can see, when I press execute, I execute just the one line. When I execute one line, this line, I will be changed to 1. Right? And then when I will jump into the G functions. And step inside, we can use the step inside, which is this one. This is the VS Code IDE. I can jump into it. Now I jumped into the G function. And as you can see, there are a call stack. Let me see, how can I move it up? Wait, doesn't allow me to move up. No, it's not. So here is the call stack, right? It says we are first executing main function. The main function calls G function. At this stage, we can also click on the main function to see where are we calling it. And here are the place we are calling it. And we know here the variable I equals to 1. How about let's get it into the G function, right? G function will, when we call this function, we will assign I to C, the parameter, right? And C should get the value 1. 1 is from I, right? And we haven't executed any line yet. So all these numbers, the remaining numbers, are just some random numbers. Yeah, N and the A are just the random numbers. And again, you can, yeah, question?
How does it already know A and C before it's defined, right? It's
Yeah.
still on 16, but technically it shouldn't even know A and C, right?
Yeah, so in C++ compiler, they knows all the variables you have defined. Yeah, it's different from other languages. So they are strongly typed. You have to first define this type, right? So whenever they read it, the compiler already knows it, and they have allocated some space for it, and they call it N, they call it A. But just some values are initialized with some random numbers. All right, and by this way, you can continue check it, right? Whenever N equal to 0 is executed, N becomes 0, then we can see if A assigned to C is executed, we can continue to run, right? A becomes C, which is 1, right? After step by step, you can check the variables here. And if you want to jump into the F function, right, you can still do that. But inside F functions, you only have N and a C, right? And C will get the parameters you pass from the previous one. As you can see, the cos F becomes main, cos G, cos F. And you can also click on where does main call G, right? Where does G call C, call F? And how does this parameters are passed into the functions you call? So here, this one is a very powerful tool. You can test whether your code are written good or bad. So you can test it and check in every step. You will see what's the value of the including the local variables. Right? You don't have to print it. So any questions on this? This one is about debugging. Whenever your final output is not correct, you can try to debug it step by step. All right. Very straightforward. Let's go to, yeah, I've already covered functions, I believe. Yes. Let's go to vectors. So we have already covered what is branches, right? If, else if, and nested if else, and many levels of else if, okay? And also switch case statement. We said switch case statement are very limited usage, just for comparing integers, and also loops. Right? We covered while loop and a for loop. We also covered do while, but we said it is exactly the same as while, just we will execute the first iterations always. And the functions, right, we say we should view functions as a black box. And how can we pass the parameters? How can we define the return values? We already introduced them. So what's the point of introducing arrays and vectors? The question is, we will encounter many examples that we require to store the same type of data. Right? We will use the same type of data, like the student. Everyone is a student. Then we can use an array of vector of student to store it. Or we have a bunch of doubles, right? We want to keep them in just one place instead of using many different variables to store them. And the array and the vectors are they are placed in continuous memory locations. So this is very important. They will occupy continuous memory locations. So in the future, you will learn something called a linked list. They have some pros and cons compared to vectors, but the one disadvantage of linked list is about they are not in continuous memory locations. They need something like the pointers to point to the next element. But in vectors and arrays, because it's continuous, we can very easily access the next item. So array is the old way, especially in the C, right? Vectors are the new way in C++. It's actually not new, very old actually. But there are still many people like to use arrays. But I would suggest all of you to use vectors in this class, including your homework, all your homework, use vectors. The reason maybe today I don't have time to talk about why arrays are bad, vectors are good, but I will show you some examples maybe in next lecture. So always use vectors. All right. The reason is more about the stabilities. So experienced programmers versus the new programmers are experienced ones, they will tend to write programs that's more stable and have less bugs, less errors. If you use arrays, you are more likely to have some bugs and arrays some of the errors. But using vectors, it's less likely you will introduce errors. And we will cover something like how to use vectors to collect the data, how to use it to access, how to manipulate, how to pass vectors to functions, right, as a parameters, and to learn some of the common array algorithms. And we will learn how to use one dimension and two-dimensional arrays. In our homework, we require two-dimensional arrays. We will introduce how to use vectors to define a two-dimensional arrays. So here is an example. Suppose you are trying to read a bunch of salaries, and you want to store them, and then you want to output something like this, and output the highest salary using a pointer to point to it. There are multiple ways, right? You can define salary 1, salary 2, salary 8, salary 9. But assuming you don't know how many workers are there, so you don't know how many variables you have to define. And these are isolated, right? Maybe salary 1 or salary 0 will be a number that represents something else, but all the others represent salaries. Instead, we can use something like this is the old array way to write an array, right? We define a salary. This is one variable. It's a variable to represent an array. It has 10 elements. Each element is type double. So here is how we can define it. And we say continuous, here we mean continuous. If you look at how they consume the space in your main memory, this is the start, this is the first element, this is the second element, this is the third element. They are continuously allocated. Yeah, I haven't talked about the first one. This one, right? This one is the old way to write the arrays. This one is the new way to define the vectors. It's a vector. The type is double. The number of elements are 10. The variable name is still called salaries. Here is the formal way to define a vector variable. We say vector, then type name, right? Like the double or int. And it can be also other types. If we want to define two-dimensional vectors, inside is another vector. And this is the type, right? For each element of the staff, for example, every staff is a type of employee, and we have 20 employees. We can define something like this. How can we initialize it? We can do something like we have a vector v. The type is integer. We can initialize it with 4 numbers, 1, 2, 3, 4. Right? I mean, using this way. And also we can initialize a vector similar, like the second v, integer type, and 4 elements. Each element is 10. And the next one, we can use the second vector to initialize the third vector. Right? We put second v inside the parameters, or we call it constructors of a vectors. Right? We will learn more about when we talk about the class and the constructors. How can we access a specific data? We can access it using the brackets. So salary 4, assign a 35,000 to salary 4. And the number inside of this bracket is called an index. We call it an index. Here is the index, right? Salaries. We said total is 10. The index is starting from 0 to 9. And when we say 4, right? Salary 4 is actually the 5th element of the salaries. First, second, third, fourth, 5th, right? Salary 4 is the 5th element of this factor. So when we assign 35,000 to salary 4, it's actually put it in here. Then if we try to access an element that's not in our vector, we will have some errors. Right, like here. If your staff, each one is double, total size is 10, you want to output staff 10, right? The problem is staff only have 10 elements. Staff 10 is the 11th element. So it's out of the bound of the vectors. There will be some errors when you run it. The question is the compiler. Compiler will generate no message for it. Compiler will assume you are doing good work. But when you run it, there will be problems. Yeah. What's happening behind it is if you are trying to assign something to staff 10, you are actually assigning the value to something that you don't know. Maybe it's some place that in the stack or in the heap, some place you don't know. And yeah, this way, right? How about this one? We define a new vector of double called salaries. We assign salaries 0, right? We assign some value to salary 0. Will it work? So when you define a vector, it's actually size 0. So when you assign 3,000 to salary 0, it's actually the first element of the salary, right? But for now, salaries are empty. So 0 is out of your bound. Let's see if I have the code. The reader. Let me see which one is it in the test. Yeah. Let's look at this example. We define a vector, right? Well, I'm opening another terminal, you can read it. So I call it a test, right? Minus all test. So if you want to use vector, you need to include this vector library. And you can compile it like the easiest way. And you can run it. Let's see if there's any problems, right? Segmentation fault. Because we have defined a vector, but it's empty. But we are trying to access the first element of this vector. Right? Because it don't have any element, you are trying to access the first one, it will be some errors. But as you can see, when we compile, right? When we compile it, you would say, all right, the compiler should know that this salary is empty, right? It should know this one is out of the boundary, but the compiler doesn't say anything. That's the C++ compiler. But when you run it, actually run it, it will have some errors. Any questions on this? When you check the C++ library, C++ vector, go to this website, c++.com. It will tell you many functions it can use. And this one is called operator. Right? You can access the data like this. My factor, brackets, this. And there's another function, actually, they call it at. You can access the element at which index. I have also shown here, right? Let's see what will happen if we call it at. At and the brackets are exactly the same. Just a different ways to write. So let me compile it again. Right? Still nothing. When we run it, it will have some errors. It will throw some of the exceptions. So this at will first check if this one is out of the boundary or not. So it won't allow you to assign the values to some unknown locations. It will check the boundary and then will say this n, which is 0, is greater than the current size. Then it will be it will stop your execution. So these are two different ways to access the elements, but most of the people are getting used to the second one using brackets instead of the at. At is the it's not so straightforward. The using brackets is more straightforward because of the old C styles. Any questions on this? This is access one specific element of your vector, right? So if you write it in different ways, such as make the size 1, right? You define a vector salaries is double. You can make it the size 1. Then it should be no problems, right? Let's see if we can compile and run it. Compile and run it, right? No issues. So here we have to remember that this index, right, is actually index plus 1 element of these vectors. So you have to make it inside of the bound of your vectors. Let me come back. Here is how we can get the size of a vector. V is a vector. V dot size will return the size to you. And so you can put it into a for loop. Right? Here's the typical writing of for loop. From the I or 0th element to V size -1 element. So you can do something with this. Right. So this for loop will start from 0 to V dot size -1. V dot size is the size of the vector. This is how we can iterate through all the elements of the of a vector. So how can we insert new variables, right? Insert a new data into our vectors. Here is the function called push back. Push to the back of your vectors. You can define an empty one. I remember when we first defined vector double salary. Salaries is an empty vector. And you can see the number, then keep pushing back to it. So later we will see difference between this one and arrays. arrays, you have to first define the size, right? And put data into it. But for vectors, you don't have to do it. You can start with some empty ones and keep pushing back into it. Just pushing the data into the back of the vectors. And internally, how they will do is none of your business. You will know they will make it correctly, increase the size, right? Because it's using continuous memory locations. They have to allocate some memory locations. They have to put some data to it, right? If it touches the boundary, like another variable have defined just below it, it has to create another bunch of locations so that it can fit this this number of data you have pushed into it. And again, this you can find it in here, right? All these functions you can use it. This one is called the pushback. Pushback means add a new element at the end of the vector. Right. This one. And also other functions, if you are interested, you can read them. Something like the in place is something similar to pushback, but we will not introduce in today's class. If you are interested, you can go there. Here is what we can do, right? We first define an empty salaries. Then we can iterate from I from 100 to 1000, and each time we increment I by 100. So you start from 100, 200, 300 until 1000, right? Then we will push back into our salaries. At the end of this program, what's the size of the salaries? If we call salaries dot size, what will it return? 10. How many elements in here? Yes, equal. 10, right? Yeah, 10. Great. So here is how we can push back, right? And how can we access it? If we define it to be 10, right? Another way, if we initialize it to be 10, then we can start from the salary 0 to salaries size -1 equals I times 10. So they are slightly different, right? This one start from 100, this one start with 0. But anyway, so there are two ways to access to push data or assign data to salaries, right? If you already know the size, if you already know what's the total size, you can put a number in the initialization. If you don't know the size, you just keep pushing back. Any questions on it? Two ways of initializing for the vectors, right? Pushback is actually very powerful. We don't care about the actual size. But for the second one, if you write it not correctly, for example, if you put an equal here, it will be out of boundary, right? If it's b dot salary dot size, then sometimes it will be out of the boundary. You need to be very careful about this index. Question? All right. So another function that's similar to pushback is called popback. You can pop the last element of a vector. They are working in pairs, you can see. All right, so one exercise. Suppose you have to write a program to read a listing of data. Then you want to mark the highest salaries like this. Right, how can we do it? So all the exercise I put in the slides. When you are, for example, learning beforehand, you can try to implement it. Right, let me do something here. salary factor. Right, we can include IO stream, include the vector using namespace std. I have defined a vector for salary. For now, it's empty. Right? For now, it's empty. Then we use a boolean more to control whether we have more input or not. But indeed, we don't need to do it. Right? We can check, yes, but we can see later what's the problem. And then we define the next salary actually we want to get. Then we print. Please enter a new salary, right? Then we can see put it into the variable s. If s equal to 0, it means this is a sentinel, right? We want to stop entering. So if it's a 0, we want to stop. We put it more, put it false to more, then next round it will jump out. Otherwise, we can push it into our salaries. Then how to find out the highest salary, right? Here is how we can find the highest salary. We can first set the highest to the first element of the salaries. Then we can iterate from starting from 1 instead of 0, right? And then it should be less than the size. And then if current salary or salaries I is greater than previous highest, then highest will be assigned to the current I. So we can iterate through this the whole vectors. Let's see how it works. Clear it. And let's call self vector. Right, let's run it. Please enter a salary 1, 2, 3, 5, 4, 0 to quit, right? This is the output we want to get. 1, 2, 3, 5, 4. And we use an arrow to show this one is the highest value. Right. And in here we can check. Indeed, maybe it's better to show it in the VS Code, show you how to debug. This is the array. And the cell fact. Okay, it's still open. We'll close it. All right, this one, right? Let me put a breakpoint here. See if it will work. Right. Now it's maybe it's not going to break here. Anyway. So it asked me to enter a new salary, right? If I enter 1, let's see what will happen. Now this S, right? S is the input. S is the input will becomes 1 because we have already seen into S. And the salaries currently it should be empty, right? If we click on it, there's nothing, it's empty. And the highest currently is also highest. We haven't defined highest yet. It should be some random number. But anyway, let's continue. If s equal to 0, is s equal to 0? False, right? It will directly jump to the else part, and it will run salaries dot pushback s. Keep an eye on this. Currently it's empty. Let's run it. Run it. Right? Now salaries have something, and we can click on this one. It has the first element, index 0, value 1. Right? That's what we input here. And we can continue. Right? We can enter another one. For example, enter a 2. Again, s not equal to 0, so it will directly jump to the else part, line 19. Go here, right? For now, s equal to 2, and let's look at salaries. it still has only one value. Let's execute this line. It will be another one showing here, right? This is the index 1, value is 2. And you can continue checking that to see if the values inside your vectors are exactly the same as what you have pushed in here. So let's directly put a jump in here, right? Breakpoints in here and let it run. Let's input 3, 5, 4, 0. All right, so here is the salaries. Wait, how can I remove it? All right. Right, here is the salaries. Now it has 1, 2, 3, 5, 4. 1, 2, 3, 5, 4. And we can also check, does it include my 0 or not? Right? But here it's not including my zeros. We don't want it to store our zeros. So it's correctly matches our behavior. And we can also see we said set highest should be the current highest, right? Let's see what's the highest. It's not allowing me to do that. So highest currently is 1, which is the first element of the salaries. Then we can iterate from 1 to its size, right? The size is size should be 5, right? I should be less than 5. So I will iterate from 1 to 4. So when we go here, if this I becomes 1, and now we are comparing salaries 1. Salaries 1 is 2. We compare it 2 with the highest. If it's greater than the highest, we set the highest to be the current salary, right? We set the highest. Where's the highest? Has this gone? The highest becomes 2, right? And we can do it over and over again, and you can check if the highest satisfies the specification you have given. Any questions on this? No? All right, let me stop it. And there's another way that you can check is the print, right? Sometimes people would like to print something for debugging. You can write some function like print salaries, and you can define print here. Print a factor of double. Right, you can print. So one way to debug is each round in here, right? Each round when you push it, you check the salaries, and you can define some function like the print. Indeed, in here, just see out some functions, see out. You need a for loop, right? You need a for loop. For loop int I equals 0. I less than salaries dot size plus I. See out salaries I with a tab so that you can see it clearly. See out a new line, right? You can do something like this. And you want to find out whether these salaries correctly getting the data, getting the input you want. So let's try it. We can compile. Let me clear it. And run it, right? If you input 1, right, it will output the current salary factor. if you input 2, right? The counter vector. If you input 3, right? Counter vector. So there are multiple ways to debug. The easiest way would be using the IDEs. If you don't have the IDEs, just print them out. Print them out and to see whether it is expected, right? Any questions? If no, let's stop it. All right, so yeah, as I can see, there's one thing that I have written. I have written something that's very similar to our homework, which is the largest instead of second largest, right? These are the we make clean. These are the folders, right? Should be included in our largest folder, make.cpp makefile. I have written the makefile for you, which is the only thing you need to change is the executable name, right? Executable name, and if you want to, yeah, someone asked me what's this? This is a tab, and this is the key in the tab, right? It's the tab key. You have to use a tab. It's the rule. And if you want to include something like the std in here, like dash std equals C++, for example, some standard. Typically, I use 11, but if it's 11, you don't need to include it. Most of them will be included automatically. You can change it here. But for your homework, I believe you don't need to include any other libraries. Right, so we can do make, right? And we can run the largest. Typically, we don't print out anything, right? In our sample output, we don't print out anything. We want to find out the largest number, assuming we input 4 numbers, 1, 2, 3, 4, right? The largest number should be 4. So this will be the sample input and the sample output. You might be interested in how our TAs will grade the homework. Let me show you. So we will not type in this one again and again, right? It will take TAs maybe a few days to grade all your homeworks. So we will put something like the, let me copy the file. This, yeah. So what they will do, they will put some numbers in input.txt. It has 14 numbers, 1 to 0, right? The largest number should be 13, right? So what they will do is they will prepare this kind of files and run your program like this. And you should output 13, right? This is how they do it. This is called redirection. You don't have to know it. I just want to show you, they will test you with a large number of numbers. Don't assume TA will only type in maybe 10 numbers or 20 numbers. Right? The numbers they will give you may be very large. And they, as long as they put it into their input.file, file, they will get a number. And also, your output could be generated to some another file, right? Output.txt. So they will save the output. If you want to look at what is your output, it's the thing, right? How they will compare it with their correct ones. They will prepare another one called correct output, right? They will have some pairs like the input, they have correct output, and they will run your program and generate some output file. Then they will compare two files. The way they compare is called diff, which is difference output with correct output. Right? If nothing happens, it means it's right. If your output is wrong, for example, if your output is not 13, it's 12. If your output is 12, they will see some difference like this, right? All right. The only thing I want to tell you is that they will test you with a lot of number of inputs, right? Don't assume they are typed in manually and assume the size of your arrays, size of your vectors. Don't do that. Any questions on this program? This program is easy, right? All right, so how can we modularize it? Remember, readability is another issue. How can you modularize it? If this is the function you have right? So at least to improve your readability, right? Put something in here, right? You can say, start reading. Start reading some data, ends with this 0, and so on. And in here, put some comments, right? Compute the highest, something like that. So you can split your whole program into different blocks. Right? This block is reading. This block is computing the highest. But even better, you can do something like these 6 lines. Right. Define a function. Not define. Double. Compute highest, right? It's a factor or something like the next one. Factor of double. You can return highest here, right? Create some functions that will group the same, maybe the blocks, and will compute an independent functionalities into one function, give it some name that other people can understand, right? And give some comments to very easily to give us some hints, right? What this function will do, right? Do something like this. This is called modularize. Split them into smaller ones so that other people can better understand your code. Any questions? No questions. All right. But here is the solutions, right? Get salaries from input and compute the highest salaries. We have already walked into it in step by step. You will see how it works. So another one, right? You can write a loop that fills a vector v with 10 random numbers between 1 and 100. Can we do that? We can use some functions like sran and rand to generate random numbers. It's not the core part. But the key part is how can you fill a vector v with 10 random numbers, right? The only thing you need to do is generate some random numbers, then fill in v with pushback. Right? You can try that offline. All right, so we have got into more important thing, which is the vector parameters. We want to use vectors as the parameters. So similar to our previous one, which are this one, right? As you can see here, we use vectors as the parameters for a function, using a vectors as a parameters for a function. So the major issues with this is that they will copy. Remember, we will copy everything from the main to here, to the parameters. So actually you have two copies, right? One is in the main, one is in the print function. If the salaries has huge amount of elements, it means you are wasting your space, right? You are copying every element of the salaries. So that's the issues we want to point out. Like this one, we want to compute the average of a vector B. Right? This is a very easy one. We don't need to go over all of them. But the question is, this when someone calls average with their vectors, they have to copy all the elements from the caller to these callees. And it's very inefficient, especially when the vectors are quite large. Because we have to make a copy of all the elements. So what's the solution to that is called a reference. The values are somewhat separate variables, right? Even though, for example, in here, let me see. Right, when you call print salaries, and when you call print salaries, salaries will copy here. Even though these two are exactly the same name, they mean different variables. This is the salary belongs to main. This is the salary belongs to print. They call it the exact values. They will copy all these elements inside a vector. And we can use a reference to do not create a new variable, but actually create a new name to it. It's just a new name. And any change in the reference parameters will cause a change in the callers or in the another variable it refers to. Here is an example. This end sign, right? This end means it's a reference. V is a reference to another one. And whenever you change V, whoever calls raise by percent will be changed in this V. This is called reference. And we can rewrite our functions, right? In our print function, instead of copying everything by value, we copy them by reference. It's doing this. This is the only change you need to make. And also in here, right, compute the highest, we can do something like this. When you do this, right, when someone else calls your function, they will not copy the values here. They will just give a new name. The new name is salaries. Right. So whenever you change anything inside your print function to these salaries, the outside, the salaries in the main function, they will also be changed. Pardon? Any questions? Okay, so let me show you an example. So reference, right? Let me see if I have one. Yeah, we have simpler examples. We define an integer for a num. It is 1. We can define a reference value called a reference num. It's just a variable name for a reference num. It assigns to num. And by this way, we are not creating the second variable reference num. We are actually getting a new name to num. So whenever we assign 11 to number, we change the value number. You can try see out number and see out the reference number. Reference number will also be changed because these two guys refers to the same object. Right, let's try it. I need IO stream. Wait a minute. Let me quickly type it. Right, so this is the function, and we can compile it. This one is test 2. All right, as you can see, initially number equals to 1, reference number is assigned to refer to number. When we change number, print it 2 elements, right? 2 elements, because whenever we change number, we also change the reference. Remember this and sign. And sign, when we put and sign, it's just renaming it. And also in here, right, whenever we change the renamed one, reference number, the original number will also be changed. The original number will also be changed. So it's not actually creating 2 variables. It's actually creating 2 names. So if we remove this and sign, right? If we remove this and sign, when we compile and run it, as you can see, 11 and 1, the initial one doesn't change, right? When we assign the second one to 20, the number doesn't change. So in this way, we are defining 2 variables. They are pointing to different locations, pointing to different parts of your memory. So yeah, if you want them to point to the same thing, you just put an and sign here, right? That's the way you can define a new variable, a new name to it. Let me see. Does it matter? Maybe. Try it. Yeah, it still can compile, right? It doesn't matter. Right. This and sign. Let's come back. So we say it's actually providing a new name, right, to the existing variables. We didn't copy the values. We just give it a new name. Right. So when we do compute average, we can define the parameters to be like this. Put an sign here. Like the way we put in this file. Right? We have defined 2 functions that accept references. This print also accept references. So whenever we call it, we are not copying the data, we are giving a new name to it. Any other questions on this? It's very important to understand the reference. Pardon? Yeah, we will talk about that later using constant reference. All right, if no more questions, we will continue. So what's the concern of it, right? What's the concern? If someone else implements a function that gets your vector and it tells you, okay, I will return the average for it. What's your concern of using their functions, using their libraries? What's your concern? You have already stored, you have an Excel file, right? Contains all the salaries of all your employees. And then someone tells you, okay, if you give me that Excel file, I will tell you the average of your salaries. What's your concern? Yeah, they might modify your Excel file, right? They might modify your vector V. We said it's just a new name to your data. So the data you have kept, whenever they modify it in V, your data will also be modified. So that's something you should concern. What's the solution? Solution is using a constant. If someone gives you this function type, right? They said, okay, I will accept a constant vector, a reference constant vector, and I will return the average of your salaries. It means they will not modify anything in V. They will just use your V, right? They will not modify the data. So that's the meaning of const. How should const be used? Let's see, right? In our print function, right? Typically, we don't want people to modify something when we just want it to be printed. So we can put a constant here, right? Constant reference, salaries shouldn't be modified. Then we can trust that this print will never modify my salaries. And let's see. Maybe I haven't finished it. I need compute highest. Wait a minute. Double highest equals compute highest of my salaries. Let's see, does it compile? Oh, it has an I that's never defined. Where is the initial I? Here. Okay. Right, it can still work, right? 1, 2, 3, it can still work. Maybe it's not easy to see. All right, that's the correct way to do it. What if, when you give a constant vector, people trying to change it, right? What if people trying to change it? They can say salaries. Maybe I know I am the salary 0. I want to double my own salary. Right? Can I do that? When we compile, it will start to complain, right? When we compile, that in this function, it accepts a constant reference and assigning of a read-only location, right? We said a const means read-only. And whenever it accepts a constant, you are trying to modify the data, compiler will start to complain. You are trying to modify the data. So in that way, you can protect your data, right, from being modified by other functions that's maybe not written by you. And on the other hand, for example, if I don't use a constant here, you can see it can be easily modified. Right, let's try 1, 2, 3, 4, right? In here, each time I'm doubling the salary 0. This is when these parameters don't have a constant in here. We can easily modify any value of your data. So it's a good practice to always use a constant here. Whenever possible, use a constant. Including the previous function, compute highest. If I don't need to modify anything, put a constant, right? Whenever possible, put a constant.